at it, might as well also record some competitive programming videos. Maybe more recreational side, nothing too serious. Because, well, the serious learnings can get a little bit fatiguing, perhaps. Let me just read the problem statement. Can read increase any the array indexes or elements by 1. Choose the index and replace AI with AI plus 1. Can choose the same index multiple times. Okay. I think I read the statement before, so I'm just gonna skip ahead. Have balanced remainders. So in the end, you want to make a few operations until the number of elements with each remainder is the same. So that's fine. So they want the minimum number of moves needed to accomplish that. So I wonder if I should take a global or a local view to optimize this process. And what I mean by that is, for example, if you need, in this example, for example, you want 2 elements with remainder 1. What's the fastest way to accomplish that? Well, looking a local view, then the fastest way is to increase the element with remainder 0 by 1. But that might not be the most optimal solution global-wise to do that. I wonder if there's any impact of increasing 0 or increasing this element with 2 remainder twice to get here. Does it matter? But I guess there's only 3 remainders, so either way it cannot be too hard to figure out, hopefully. Maybe I will scratch some things down on my notepad and see if I can figure it out. If I can, I will present a hopefully reasonably elegant solution. If not, that's fine. I'm here to try this after all. So I'll just scratch this down quickly. So I guess there's a unique characteristic in that you can only increase the remainder. Of course, like it turns around, but like you can only go right way. You cannot decrease and go from 2 to 1. You're only going up. So I guess you're forced into a certain pattern. So for example, in this case, you must go from 2 to 0 and 0 to 1 to distribute this correctly. So really, I'm beginning to think that if you have too much or above average number of elements in one remainder, you just have to distribute it to the next. All of your extra parts, no matter how much you have, because there's no other way you can go back, so you have to push it forward. So I guess that's the greedy way to think about it, I suppose. And there will always be a element which is in excess in terms of how many elements there are. Otherwise, every one is equal to the average, and there's nothing to do. So guess I can program that up. Should be relatively straightforward. Let's look at the ranges. Okay, it doesn't look like there are any really big numbers. Looks pretty bog standard numbers, very small numbers. In fact, make sure I didn't miss anything. Okay, so we want an int array. Okay, makes sense. So we're going to have a small array. I'm going to call it remainder counts. I'm going to mem set them to 0. And I'm going to import string dot h for the mem set. And okay, so this is the tricky part, or so-called, I guess. Do sync. It's gotta be multiple of 3. Yeah, it is. Good. I should have put this up here so that I could increase it. That's reasonable. So if the rem count is greater than the average, no, there's a problem. If they're all equal, which we assume is true, now equals false. If none of them is greater than the average, then they all have to be equal, because otherwise they're all lesser, which doesn't make sense. So one of them has to be greater, or all of them are equal. If one of them is lesser, then the two equals don't make up for adding up to n. So that's the logic, I guess. If all equal, we're done. Just 0 moves. And we can go to the next iteration. If we have some, okay, trying to adjust the microphone. If we have some other scenario to pay attention. So I guess I'll use the remainder. So I guess I will do this. I'll try to animate this process. And that's fine. So we know that this is the index which has a greater remainder than the rest. So the question is, I have to push it forward, otherwise there's nothing to do. So I'll start from max index. Maybe I'll put it in terms of the increment. Oh, I'll put the current index as, so probably I start with the max index and I mod by 3. So if current is greater than the average, we need to push it into the next. We need to add 1 to everything here to see how much the difference is. And so that will cost at least diff number of moves. And then we'll subtract. I mean, I really shouldn't be actually modifying the state, but I'm too lazy to do it without it. So I'll do it anyways. I'll push it into the next one. So that's exactly what I'm doing. So ideally, that should be the solution. I'm going to try it out. I use C++ 20 because why not? Okay, that's the wrong answer. Why is it the wrong answer? Oh, shouldn't have full screened it. Okay, it says it's taking 2 moves, so I'm gonna have to investigate what's going on here. First, I'm going to print out the remainder counts and see if the counts are accurate. So I'm gonna print out the counts. Oh, keep doing that. Sorry about that. So it looks like the count is quite accurate. So I wonder why it's only 2 moves. Going to print out the increments now and how many moves were taken at each increment. Oh boy, I screwed up the input. Okay, so it says it takes 2 moves in the first step, which is going from here to here, presumably. But it remained as, oh, I'm stupid. I need to also increase the next index. I have to be careful to mod 3 by diff, because I just pushed it into the next one. That should work, I think. Yes. Okay, so I'm going to try and comment out. I'm gonna try a trick, see if I can do it right. I probably cannot. Okay, I'm trying to replace the pattern. I wonder if I can do it. Replace pattern. I'm not very good at Vim, so I guess it'd be nice to learn. Oh boy. So .s, put the first pattern here, the second pattern. Okay, fair enough. I want cout, everything containing cout to be commented. So would it look like this? No. Of course it cannot even, but I can't find the pattern cout. So, oh, so and I can also replace it with nothing. If I do this, I bet there's some there's some escaping character issues in the pattern. Okay, maybe I should. So it's regex. There's some regex situation going on here in the Linux. Yeah, this all seems fairly harmless, but there's no weird characters to escape. Is there any guidance on the backslash? Yeah, I guess find search is close enough to replace pattern with a backslash. Oh. Okay, I mean, that sort of makes sense, I guess. This is how you would. Oh, no, I'm not supposed to put the parentheses. Okay, now I'm confused. I did this already, or is it? Okay, so to escape this backslash, put a forward. Oh, sorry, to escape the forward slash, you put a backslash in front of it. But what about a backslash? Escape forward slash, or I guess, huh? You don't need to escape them. You could use a different separator for the search pattern. If you really want to escape them, you can use the backslash. Oh, that's pretty crazy, huh? Or can I do this? No, that's not. You can't do quotes, they don't really escape. Oh, that miraculously worked. Okay, so what if I want to do the reverse substitution? I can do this also. Yes, I can. Okay, so I guess that's how you do it. Yeah, it's a bit uncomfortable, but I guess if it works, I'm happy. I don't want to remove all of the counts, so let's see also. I want to keep the ones that actually are important. Oh, go back here. Just take this and try. Okay, so there is another mistake here. Okay, so it thinks it's 2. Let me try to reason visit. See what's going on. Okay, so 441. So based on my understanding, would ideally like to move this 4. So first of all, the average is 3. So move 1 from here to here, and then it would be 5. Then you move 2 from here to here. Okay, that actually seems consistent with the REMs displayed here. So what's wrong with the moves? To try and figure it out. Oh, what did I do? Okay, so one move first from this 4 to this 4. But why only one move again? This should have been increased to 2 moves by increment 1. Because it should have moved 2 from 5 to this. From index 1 to 2 increment, I guess. That's puzzling. Not quite sure I get it, actually. Let me print out and see if the next index has been affected. Okay, next okay, so oh, that doesn't seem too right. Oh boy. Okay. Next frequency 2. Difference is 1. 1 on the first one is correct, but next frequency 2 is definitely not correct. That's wrong. +1 mod 3, that seems reasonable. Why is it wrong? I guess I'll break it down more specifically. Yeah, see, the pace I'm going is too slow. This is not how you do the programming, man. Like, I'm too out of shape at this point to actually do anything interesting. Oh, crap. Okay, so next index is 2. The max is 1. Oh, I guess that works. 2 question mark. Does it? No, it doesn't, because this has nowhere to push. You have to start with the first element which exceeded the max, and then break. Because you have to start pushing from there. Oh, okay, I guess that's a special condition which I didn't really consider. So that's not really, that's actually an implementation error. That's not a detail. It's actually a problem. Yeah, I should have considered that. Yeah, see, now it makes sense. Gonna upload it. Let's see it. Takes a while. I'll look at the next problem. Oh, I did this already. Me XOR. Oh, that looks horrible. I hate these XOR things. Oh, wrong answer. Okay, good. Don't have to look at the XOR it means. Okay. Where did I screw up? 9s. Which way the 8, 5. Oh, it's not really displaying the 9s. Is it? 4, 5, 6, 7. Okay, it's not showing the 9s test case here, but the expectation was 8, but 5 was found. Okay, so how is it that I found a shorter pass than the actual solution? Unless there's a case where the max end was to start with, and then you drop off in the middle, and then there was another one at the end of the cycle. That must be the case. Okay, so now I have to think. So if the current index and the next one both exceeds the remainder, you want to start the cycle at the current index. Otherwise, okay, so we need to break it down in the casework. If there's 2 remainder counts both exceeding the average, then you want to start with the one that's first in the cycle. But I guess it doesn't matter, because it just depends on where you start. And you have only one exceeding the average, then it doesn't matter where you start. No matter what you do, it will be fine. So I guess that's the idea. I suppose. But then that requires me to actually figure out how many that exceeds the average or something like that. I guess that's the traditional way to think, or silly way to think about it. Put exceeds plus if exceeds is equal to. Is there always a way to? Yeah, I think so. There's always a way they're consecutive in a cycle. Then I have to retarget what my maxim is. Just loop to 6 to be safe. I don't want to screw around too much. Okay, so I want to put the new max index here. Okay, I should have. No, but I'm too lazy to do it. Just gonna do it this way. Just break out of the for loop then. So I'm going to give it a sample test case to target this exact situation. I'm going to give so I'm going to give a test case of a lot of remainder of zeros, a lot of remainder of twos, and not a lot of ones. I'm going to try that. How about that? So a lot of zeros. Wait, actually. Okay, so zeros and twos. It told me 3 moves. So first move 1 from remainder 2 to 0, then move 2 from 0 to 0. Okay, that looks right. I'll try with this. That looks right again. Alright, so I think that makes sense. Okay, cool. Let me read the tutorial. That was a bit of a silly one. It was actually made by Mike Mirza-enough. Okay. Yeah, this is relatively more. Yeah, just move it. Cyclically shifting. Yeah, this is more systematic, I think. Better than my solution, I think. My only loop once. I feel like if you loop at least 2 times, yeah, like it, just checking everything is the average. Loop as many times as needed to reach that condition. It won't be too many times. I think I try to optimize too much for the number of times you loop when it's very not relevant. Okay, then just go to the next one. That's the good thing about this is even though I was quite slow, I still can solve the problem at least. That's the difficulty I want to train at probably. Is equal to A, X is equal to B. This does not belong to. Jeez. What is shortest possible length? Okay. Jeez, okay, I have no freaking clue. There's some clever manipulation tricks going on, and I don't even know what what to do here. Yeah, I guess it's gonna be slow and painful. So the minimum excluded is the minimum non-negative integer that does not belong to the array. XOR is just the bitwise XOR. Okay. What is the minimum non-negative integer? So I guess whenever there is a gap, then you'll find something there, pretty much. So I guess the max is not too hard to follow. So I guess you put down the max first as a condition first, and then you try to construct the XOR. That makes sense, I guess. But now I think I need to reason about the XOR. I'll jot this down briefly. So the minimum excluded really requires all of the integers less than to be inside the array, which means that you will need an XOR of all the elements less than that value. Probably you can memorize it because you'll probably use it quite a few times. That accumulated value, that XOR value. And then XOR some more values greater than that max to accomplish what you want. Probably that's what is needed. Funnily enough, these numbers all seem to be 2 or 3. Don't know if that's deceptive. Maybe it's not. Because it seems like you're trying to achieve a final value with, let's say, a0 to a in bit, and then you have an XOR value of all the integer values less than that max, then all you need is another value just fitting all of the bits that will make the first value of the accumulation of the XOR match the result we want. So I guess the result is always like max minus 1 plus 1, or max something like that. Is that true? Don't know. Oh, no, it's not true. Feck. Why is it not true? Gosh darn it. Oh, wait, I guess you fudge. Why is this not true? No, it's too hard, man. Too much work. Let's start with the first case. So first we know that the only number that's required to be there is 0 based on the max, and then what number XOR 0 is 1, and the number will be 1 itself, but since we cannot place 1, we require at least 2 other integers, and there's guaranteed to always be 2 other integers to XOR to that one, so I guess it makes sense. There's always going to be 2 integers that XOR to 1, or any other integer. So I guess all it's talking about is I need to think about this. Let's go to the next case. So 2, 1. So that means the values 0, 1 must be there, and they already mix 2, 1. So I guess there's nothing to do. Okay, so 2, 0. What about 2, 0? So you're trying to 0, 1 must be there. The XOR is 1. You're trying to make it 0. Then you need another 1, I guess. Yeah, that probably works. Okay, next 1 and 10,000. Okay, and to start generalizing this question. So let's say that we have a series of numbers, 0 up until max minus 1. We take the XOR of that value, which we assume is minimized. So let's call this some random value. And then that value, XOR, if that value is already equal to the XOR, then we're done. The result is, the answer is max. If that value is not equal to XOR, then we need to find what number is needed for it to reach XOR. If that value XOR some number which is equal to max, if value max XOR max is equal to the desired XOR value, then we can't do that. So we need at least 2 more integers. If it doesn't require max, if it XORs some other number to reach the desired XOR value, then we just +1. I guess that's the final idea. Okay, I think I can write this up fairly quickly. Well, that wasn't too bad. I don't know if it's bad or not. I haven't done it. It could still be bad. Let's see it. If I can put the microphone in a better place. Oh, fuck. Why did I just do that? Okay, so we got our stuff. None of these are too big, require usage of long ones. That's good. So I'm going to minimize the XORs inside some array. Because why the heck not? What's the limit? It's 3 times 10 to the 5. Okay. That looks right to me. Oh, what am I doing? I wonder if that's going to take too long. Actually, I think it's going to be perfectly fine. I mean, it was 2 seconds. We're hoping for if 10 to the 9th instructions per second, roughly. We're looking at quite a few orders of magnitude more than 10 to the order 5. So it looks reasonably okay. I guess. Yeah, I'm just gonna do this. Looks okay. Well, first I'm gonna actually print, because I don't know if this is right. I'm gonna go crazy and print too much, probably. So I'm just gonna go until 10. See if it works. Oh, wait, what am I doing? Let me just, oh, sorry, I didn't even receive any input. It just prints this first, right? Yeah. Okay. I'm just gonna check the first few. Too lazy. Yeah, 3 is right. 3 XOR 3 is 0. Yep, that's enough for me. I'm just gonna put maybe. Is it define? Max as this number. I wonder if I can do this. Let's try that. from macro. So I guess this needs to be a constant. That is not a macro. Okay, fine. Can't do this. Okay, fine. Then I'll just do. How about now? Does that work better now? Apparently it does. Okay. So first things first. Well, maybe I'll give it descriptive names. XOR result. Okay. So what I will need is, can this be 0? It cannot. Okay. So first off, the max, so everything that's up until 0 XOR up until max minus 1 is your max minus 1. Okay. And then if there's some of these three cases, if the max XOR is already equal to the result, we are done. And we just want max minus 1. Or sorry, max as the result. Else if max or x or the max is equal to our XOR result, then we gotta put x plus 2 because we need 2 extra integers to accomplish the task. Otherwise, it's gonna be just max plus 1. Hopefully that does the job. Oh, lower precedence. Oh, that's actually a very good reminder. Without that, I would be dead. Oh, okay. I'll need to print that. But the result looks right. Yeah, the result looks right. Going to submit it. Yep, okay. That's actually one of the smoothest max or XOR problems I've ever done. Looks easy. Okay, that'll be it for today, I think.